Good day everyone. We are appreciating for your patience and intentions for a few minutes. The topic of our article, automatic beam aiming of the laser optical reference system at the center of reflector to improve the accuracy and reliability of dynamic positioning. The paper addresses the issues of automatic beam aiming of the laser optical reference system to the center of reflector in conditions of strong pitching and rolling. One of these systems is installed on the supply vessel S-NAT-225 for maneuvering and holding position in the vicinity of various offshore facilities. Vessels of this type are engaged in the delivery and supply of dangerous goods to ensure continuous drilling and oil production in the open sea. Practical observations show the laser optical reference system does not receive a stable or high-quality reflection, and sometimes even complete loss of the reflection is observed in the conditions of strong waves. The laser optical reference system is a measuring system and integral part of DP system. It consists of laser unit, integrated controller, and intelligent software. The laser unit rotates or scans in horizontal plane and emits high-frequency pulses. The pulses are reflected from the reflectors attached to moving or stationary objects, platforms or vessels, and returned back to the laser unit. The distance to the object is measured by the difference in time of emission and return of pulses. Laser optical reference system, as any other positioning system, has its own risks of losing position. One of the reasons of signal loss is shading of the reflector by objects or contamination of the lens. Such problems are easily solved by correct installation of the reflector in the line of sight, cleaning the lens of dirt. However, deviation of the optical axis outside the reflector, especially in condition of strong pitching and rolling, due to the limit beam width from 12 to 18 degrees in the vertical plane, appears to be more significant reason of losing position, which leads to the weakening and even disappearance of signal. The development of the method, algorithm, and the software for the system of automatic aiming of the beam at the center of reflector, considering the angular deviation of the vessel from the initial position during rolling and pitching, is an urgent scientific and technical problem. The closest analogs are given in the manuals of the Transas Offshore Simulator, which describes three DP systems: Navis Engineering, Marine Technologies, and Rolls-Royce Marine. Each of these DP systems works with the laser optical reference system. At the same time, before starting operation with laser optical reference system, the angle of elevation of the beam above the horizon is manually set up in each of these systems, so that the beam hits the reflector while the laser direction unit is passing the reflector during circular or sector scanning. As follows from the review, the solution do not consider the possibility of increasing the accuracy and reliability of the DP system by automatically aiming of the laser optical reference system beam at the center of reflector. The closest solution involves only the initial manual setting of the beam elevation, which is insufficient during the strong pitching or rolling. The object of research is the processes of automatic aiming of the laser optical reference system beam at the center of the reflector under condition of strong rolling and pitching. The subject of research is the method, algorithm, and software for the control system of aiming in the condition of strong pitching and rolling. The purpose of research is to improve the accuracy and reliability of dynamic positioning system in conditions of strong pitching and rolling. Figure 1 shows the coordinate systems used in the calculations. The linked coordinate system associated with the platform is located in the center of vessel's rotation. The base coordinate system associated with the vessel is located in the center of vessel's rotation. The measuring coordinate system associated with the laser optical reference system is located in the center of vessel's rotation. The transition matrix A between a linked coordinate system and base coordinate system is shown in Table 1, where phi is the roll angle, psi is the yaw angle, and theta is the pitch angle. The transition matrix B between the base coordinate system and measurement coordinate system is presented in Table 2, where psi m and theta m are the angles that determine the position of the optical axis in the base coordinate system. This slide shows the projections of the unit vector direction to the center of reflector in the linked coordinate system and base coordinate system, as well as the projection of the unit vector directed along the optical axis in the base coordinate system. Conditions that determine the direction of the optical axis to the center of reflector are presented by System 1. Further, two modes of the beam aiming are considered: laser rotation or scan mode and follow reflector mode. In the laser rotation or scan mode, the bearing to the reflector is measured only at the moment when the beam is passing the reflector. The rest of the time, the bearing is predicted using the measured yaw rate. In this case, the required elevation angle is determined by the equation 2. Reduction of the beam to the required position is performed according to the difference scheme, which is discrete analogy of the aperiodic link presented in the equation 3. In the follow reflector mode, the laser model is constantly oriented to the reflector by changing the direction of the beam in both the vertical and horizontal planes. In this case, the required direction of the optical axis to the center of the reflector is determined by the equation 4 and 5. The reduction of the beam to the required position is performed according to the difference scheme, which is discrete analogy of the aperiodic link presented in equation 6 and 7. The authors conducted an experiment with the laser optical reference system SciScan installed on the platform supply vessel SNAT 225 and reflector mounted on the jack-up type platform. The figures shows the laser optical reference system SciScan reflection during the pitching is unstable. The quality and brightness of reflection is low. The laser optical reference system SciScan reflection during rolling is also unstable. The quality and brightness of reflection is minimal. A loss of the reflection from the reflector tube occur. The operability and efficiency of the proposed method and algorithm for the automatic aiming of the beam at the center of the reflector was tested by mathematical modeling in the MATLAB environment in the follow reflector mode. Figure 3 demonstrates the results of automatic modeling of the processes of the dynamic positioning of the vessel during strong pitching. Simulation results show for the pitching parameters amplitude and frequency, which coincide with the corresponding parameters in the full-scale experiment. Furthermore, in order to create more severe conditions compared to the full-scale experiment, the initial value of the longitudinal speed Vx is 1 meter per second, lateral speed Vy is 0.5 meter per second, and angular rate Wz is 2 degrees per second. It can be seen from the graphs of the upper row that the dynamic positioning system ensures the development of the initial mismatches and the subsequent retention of the longitudinal velocity Vx is 0 meter per second, and longitudinal displacement xg is 0 meter, as well as the lateral velocity Vy is 0 meter per second, and lateral displacement yg is 0 meter. The second row graphs show the effect of the pitching on the angular velocity Wx and the roll angle phi, as well as the angular velocity Wy and the trim angle theta. From the graphs of the third row, it can be seen that dynamic positioning system also provides the development of initial mismatches and subsequent retention of the angular yaw rate Wz is 0 degrees per second and the yaw angular psi is 0 degrees. The measured values of the bearing Pm and the distance to the reflector Dm are also presented here. From the graphs of the last row, it can be seen the change in the angles of theta psi scan, psi psi scan, which is determined the current position of the optical axis in the base coordinate system, as well as the angles of deviation of the current position of the optical axis from the center of the reflector, delta theta and delta psi. Figure 4 shows the results of mathematical modeling of dynamic positioning process during a strong rolling with the amplitude and frequency of roll in the full-scale experiment. Initial deviations in the longitudinal speed is 1 meter per second, lateral speed is 0.5 meter per second, angular yaw rate is 2 degrees per second. As can be seen from the above results, the rolling oscillations also appear in the trim and roll channels. Against the background of those disturbances, the DP system ensures the development of the initial deviation and further maintenance of the position, and the guidance system ensures that the beam is keeping in the center of the reflector with an error not more than 2 degrees in the vertical plane, and with an error not more than 0.25 degrees in the horizontal plane. The results of comparing the quality of the reflected signal Q for the known solution psi scan and the proposed automatic beam aiming are shown in Table 3. The above results indicated that for the amplitudes A and period T of pitching and rolling indicated in the table, the quality of reflected signal Q of the known solution psi scan is respectively 30% and 0% signal lost. For the same pitching and rolling parameter, the quality of the reflected signal with automatic beam aiming in the both cases is 100%, since the deviation of the beam from the center of the reflector in the vertical plane is 6 times less than the beam width 12 degrees in the vertical plane, and deviation of the beam in the horizontal plane is commensurate with the width of the beam in the horizontal plane 0.13 degrees. This means that the accuracy obtained by automatic beam aiming allows using the not only laser rotation or scan mode, in the which the beam position can be refined with a periodic of rotation or scanning of the laser unit, but even the follow reflector mode, in which the beam position can be refined on each clock cycle of the onboard controller. The proposed method, algorithm, and software for the system of automatic aiming of the laser optical reference system beam at the center of the reflector allow to significantly improve the accuracy and reliability of dynamic positioning system as a whole in conditions of strong pitching and rolling. The known solutions implemented in the DP systems of the Navis Engineering, Marine Technologies, and Rolls-Royce Marine provide only the initial manual setting of the optical axis elevation angle, which is not enough under conditions of strong pitching and rolling, as shown by the results of the full-scale experiment conducted on the vessel SNAT 225 with the laser optical reference system scan. During strong pitching or rolling, the quality of the signal reflected from the reflector deteriorates significantly, and in some cases it may even be lost. Such work of the laser optical reference system is unacceptable when performing dynamic positioning or maneuvering operations near oil and gas platforms. The scientific novelty of obtained results lies in the theoretical justification of design features of the original system of automatic aiming of the laser optical reference system beam at the center of the reflector, consisting in constant, on each clock cycle of the onboard controller measuring the angular displacements of the vessel from the basic position. Subsequent consideration of this deviation is used to calculate the direction of the optical axis to the center of the reflector. Bringing the current position of the optical axis to the calculated position is performed by automatically changing the elevation angle of the optical axis. The obtained results allow to significantly improve the quality of the reflected signal to exclude signal loss under conditions of strong pitching and rolling. The practical value of the obtained results lies in the development and the introduction into industrial production of the original system of the automatic aiming of the laser optical reference system beam at the center of the reflector, as well as the regulatory documentation for it being able to improve the quality of the reflected signal. Therefore, accuracy and reliability of dynamic positioning system in the general under condition of strong pitching and rolling can be achieved. Thank you for your attention.